welcome to Ben on Balls for week, who the fuck knows anymore, because we've had a whole bunch of rainouts. So today we are going to be doing fun with numbers. That's right, math. All right, so to start off, let's just say we have this. Let's say we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, etc., right? Continuing on forever. So, if we add all that up, Garrett, what do you think we would get?
Infinity. Positive infinity.
That is definitely one way to look at it. What's super weird is that there's another way to look at that. So you can say, all right, this is going to go on forever, right? Add all of those things up, add up an infinite number of things, you're probably going to get something infinite. Another way to look at that is, you can also get negative 1/12.
How?
Right? It's really bizarre, but I'll get there. So I'm gonna put this aside for now. The sum of all positive integers. So I'm gonna go introduce another sequence, okay? So this one starts with 1, minus 1, plus 1, minus 1, plus 1. Yep, oh, there we go. Plus 1, minus 1, plus 1, etc., right? This, another infinite sequence. If you add them all up, what do you get?
I'm gonna say 0.
That's not a bad thought, actually. Because, let's say, so we have the first two terms, right?
Yeah.
The sum of the first two terms is 0, right? Then we have the first three terms. Sum of the first three terms is 1. First 4, we're back to 0. 5, we're back to 1. So, if infinity is odd, we have 1.
Yeah.
If infinity is 0, or if infinity is even, we have 0.
Okay.
Now, this is a pretty famous series. It has to do with Thomson's lamp, okay? One way to look at this is, let's say if there's a 1, we have a lamp, we turn the lamp on. When we have minus 1, we turn it off. If you do it an infinite number of times, is the lamp on or off? Now, so there's two, like 1 and 0 are both valid ways to look at it, but there's another way. So let's say we call this S. This whole thing, 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc., right? So let's say we have 1 minus S. Ooh, broke the jar. So that's going to be 1 minus. I'm going to put this in parentheses. So we have 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc., right? Let's go through and distribute this negative. So we have 1 minus 1. Minus is a plus. Plus 1. Minus and a plus is minus. So 1 minus S, this series, gives us the original series. Weird, right? Which means this is some pretty basic algebra that's pretty easy to solve. So if we have, well, I'll write it over here, 1 minus S equals S, add an S to each side, that means 2S equals 1, S equals 1/2. So, going back to that lamp analogy, if 1 means the lamp is on, minus 1 means the lamp is off, you do it an infinite number of times, what do you get?
1/2.
What does that mean?
I don't know, but I'm sure you're gonna tell us.
Oh, no, I have no clue. No, literally, what does that mean? That's an open-ended question. Now, that's kind of a digression. That is just to figure out that the sum of this infinite series of 1 minus 1 plus 1 is 1/2.
So is that saying like the lamp is half on? Or on half the time?
Sure.
Which would make sense, because...
I mean, when when you're dealing with infinities, you kind of have to stop worrying about what makes sense and just what is true by the rules we've set up. Now, so if this is S, I'm gonna come back to this, getting closer to it. So now I'm introduce a new series called, let's say this is gonna be S2, okay? S2 is going to be 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8, etc., right? So every odd number is going to be positive, every even number is going to be negative. So now, going to figure out a way to figure out a value for this. So, going to add another S2 to this, okay? So we're going to add S2. But I'm going to write it just a little bit differently. So I'm just going to shift it over by 1. So we have 1 minus 2 plus 3 minus 4 plus 5. So it's all the same thing. I'm just lining it up differently, right? Minus 6 plus 7. Okay? So if we're adding these two, so we have 1, that's just 1, minus 2 plus 1 is?
Negative 1.
Negative 1. 3 minus 2 is?
Plus 1. Oh, no.
Plus 1. Minus 1.
No.
Plus 1. Minus 1. So, this series, 1 minus 2 plus 3 minus 4 plus 5 plus itself, so we have 2 of these, right? So 2 S2s now equals S.
Which was the original series.
Which is this series, yeah. So it equals the 1 minus 1. Now, which means, so down here 2 S2 equals S. S equals 1 half, which means 2 S2 equals 1 half, S2 equals 1 fourth.
Mm-hmm.
The sum, if you do this forever, you get a fourth.
So as of you're saying, you're going to get a fraction more and more so. You got 1 half, then you get 1 fourth, and then you're going to lead up to 1/12.
So, well, I'm about to get to negative 1/12, right? Coming back to that. So, over here, right, we have, going to come back to this original one. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, right? Continuing on. And now, what I'm going to do is subtract an S2 from this, okay? So let's call this original one whatever. Let's say that this is going to be like S prime. That's just an arbitrary name. These S's don't mean anything. I'm just using it to label that. Okay, so I'm going to take S prime minus an S2. This one down here, 1 minus 2 plus 3, right? So we're going to subtract 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8, etc. Right?
Mm-hmm.
So we have 1, distribute the negative, 1 minus 1 is 0. Now, we have 2 minus a negative 2 is 4. 3 minus 3 is 0. 4 minus negative 4 is 8. 5 minus 5, 0. 6 minus negative 6 is 12. So what this winds up being is 4 plus 8 plus 12 plus 16 plus 20 plus 24, etc., right? So 4, 8, 12. So now, we come down here, S minus S2, we have 4 plus 8 plus 12 plus 16 plus 20 plus 24. Keep going. Yeah, I am running out of chalk. Thank you. Now, these are all multiples of 4, right? What happens when we divide it by 4? If we extract a 4, we have 4 times, well, 1 plus
2,
2 plus
3.
3 plus 4 plus 5 plus... So, what do we have here? This is the same, and this continues, as S prime. This 4 times this, or this is the same as this, which means that S prime minus S2, which we already did up here, S prime minus S2 equals 4 S prime. Now, we already have a value for S2, which is 1/4. So, we have S prime minus 1/4 equals 4 S prime. We combine these, move this S prime over here, we wind up with 3 S prime equals negative 1/4, which means S prime equals negative 1/12. The sum of all positive integers can be expressed as a negative fraction. And what's even crazier is that this has been experimentally proven. Like, this exists in the real world. It's called the Casimir effect. It's super weird. But this is true. There are things that work that would not work if this didn't count. Now, to be fair, some math nerds out there will argue that a whole lot of this doesn't work. There are, because you're not necessarily allowed to add or subtract infinite series. This was originated by Leonard Euler, the Swiss mathematician, probably one of the 5 most important mathematicians of all time. So yeah, in a sense, this doesn't necessarily work based on the rules you learned in school, but it's a little more complicated than that. It works because of something called analytic continuation. Anyway, so some people argue that S prime does not strictly equal negative 1/12, but it's another way to phrase that. It's a value you can assign to it that is not infinite. And there's more rigorous ways to prove this, like using the Riemann zeta and a couple derivatives. But yeah, it's you can add up every positive integer and get negative 1/12. And obviously, if you stop at any time, you're going to get an arbitrarily large number. But if you do it forever, infinitely, you can get that. Weird, right?
So weird.
Yeah. Yeah, like I said, sometimes when dealing with infinites, you have to stop worrying about if things make sense and just see if they work by the rules we've come up with. And this kind of works.
Yeah, it's pretty impressive.
So yeah, this week in Dogtown is going to be the games that were supposed to be last week, except we got rained out. Are you not entertained?